So I want to continue working our way through the TypeScript slides, and I'd like to try and finish them today. Not sure if I'll get there or not, but that's the target anyway. So what we know about TypeScript already is this type annotations that we use. This is the syntax that we use for declaring the type of a variable, and here's an example of it there. This postfix syntax, as we called it. And we can also use that at the bottom of the slide there. We can use that with functions as well. Talk a little bit more about functions today, though. TypeScript supports classes, but that's really just because JavaScript supports classes. And you have an example of the syntax there on the right. TypeScript also understands the notion of interfaces in the sense that we understand it from other languages, in particular Java. We didn't really spend any time delving into that because I'm assuming that people are already familiar with them. We talked about interface data types, which is a new concept from a TypeScript point of view, and it's a way of us putting or declaring a type for a particular data structure that we will be using in our code. And you have an example there of the syntax that we use for declaring these interface data types. We then talked about type aliases, which allow you to do the same thing as interface data types do, but type aliases have other aspects to them as well, which we'll see today. Type inferencing was this idea that the compiler can do a lot of the heavy lifting for you without you having to be explicit in your code, in particular in relation to the types that you associate with your variables or indeed your function returns. And so, like I said, the last AT, I think that it's not really until you become an experienced TypeScript programmer that you start leveraging type inferencing to its maximum. And I don't really expect you to be expert TypeScript programmers by any means at the end of this module. So you may well find yourselves doing some being explicit about the types for variables when you don't really have to be explicit. The compiler will infer the correct type for you. Although it's something you should keep an eye on, because sometimes it might infer a type on a variable which is not what you expected. And in that case, maybe you have to go back and review your code to see where did you go wrong. Why is it inferring a type other than the type you thought it would be? So it may be that the compiler is wrong. Well, not so much the compiler is wrong, but you know, the inference that it's putting on a variable is not what you expected. So you need to review your code. So that's roughly where I left off. So the next thing I want to talk about is functions. And we use our type annotations on functions as well, because we have to declare the types of the parameters that are input to a function. And we also sometimes need to be explicit about the return type for a function. And so on the first screenshot, I've got a very simple example of a function, and it looks like I'm saying that this particular function, it expects two numeric parameters and it returns a numeric parameter. This is how we explicitly declare the return type. We're using this postfix syntax again, but after the parentheses and before the curly brace, which represents the beginning of the body of the function. The compiler can infer the return type for you, and it simply looks at the return statement in your function and looks at the type of the associated with the return statement, and then infers that as being the return type for the function. And that's what is happening in the second screenshot, because you can see here, I'm not specifying explicitly the return type here, but when I did a Command K, Command I on the function itself, this is what it came back with, and it's telling me that the return type is a numeric array. And if you follow the flow of control in the function, it is indeed a numeric array that is being returned by this function. So that's the 101 of functions. Now, when I was kind of preparing these notes, I was thinking to myself, well, are all the students, have they done any JavaScript programming within the past couple of years? Are you kind of up to speed, or have you kind of forgotten for some of your JavaScript? So I'm kind of assuming the latter. So I'm just going to do a quick review of functions in JavaScript and then carry that forward to the TypeScript. So we know that a function is this um, unit of encapsulation of logic, anyway, associated with the JavaScript language, although JavaScript now has classes, but classes are not native to the JavaScript language. Unlike other languages, for example, where, for example, Java classes are native to the language. By that we mean when we compile a Java program, okay, it produces bytecode, but the bytecode actually contains class-related information in it. Whereas when you compile, when you write classes in your JavaScript code, that those classes actually get converted back into certain types of functions behind the scenes. So that's what I mean by they're not native to the language. Classes are not native. Anyway, in relation to functions, functions certainly are. So when I look at functions, or when we talk about JavaScript, we tend to talk about old JavaScript versus new JavaScript, or to be more elegant about it, ES5 JavaScript, ECMAScript 5 JavaScript is old JavaScript, and ES6 JavaScript is modern JavaScript, although we're up to I don't know what now, is it ES9? But ES6 was a kind of a turning point in the language when a lot of features were brought into it. But from day one, and by day one, we're kind of now saying, if we look at ES5 JavaScript, it gave us two ways of declaring functions. We could use the function declaration syntax, which looks like this, okay? So it's a keyword function followed by the name of the function, followed by the parameters to the function enclosed in parentheses, and then a curly brace and open curly brace that wrapped the body of the function. So that's a function declaration. That's the technical term for it. We could also declare functions using the function expression syntax, which is what I'm doing here. I'm essentially assigning a function to a variable, but the variable now becomes the name of the function. You'll note here, I'm not putting any name into the function here, whereas I did up here. So this is a function expression. Really, they're just two ways of declaring functions. That's what we've had from day one. Just by the way, there's this odd aspect of JavaScript from day one called hoisting. What hoisting means is that whereas if you looked at the flow of code in a JavaScript file, and let's say you had a function declared at the bottom of the file, you could still invoke that function from higher up in the file, which is an odd kind of thing, that you can invoke a function that's declared later on. Typically, you might expect the function to be declared first, and then you invoke it later on within the same file. Well, you can, at runtime, when JavaScript code is loaded into memory, the JavaScript interpreter performs something called hoisting, which means it looks at all of the code in your file and it takes the functions and brings those to the top of the memory location. It's just something that was built into the language. And that's why in your source code, you can invoke a function before it has been declared. And the reason you can do that is because at runtime, the function is actually hoisted to the top of the memory. And that's why you can invoke it before it's declared. Anyway, that's it's still in JavaScript, and it's probably there in TypeScript too, but it's not as significant. Now, enter ES6, modern JavaScript. We can still use function declarations and function expressions, but ES6 also gave us something called arrow functions, which is just another syntax for declaring functions. And there's a shorthand version of this arrow syntax. Come back to arrow function in a second. And finally, we have something called anonymous functions, which has been there from day one. An anonymous function is a function that doesn't have a name, which might seem a peculiar thing. If it doesn't have a name, how can you invoke it? But it turns out that we use anonymous functions quite a lot, and you'll see examples of it. In a while. Back to arrow functions. There's a couple of aspects to them, but the simplest thing to say about them is that they're kind of a cleaner syntax for creating functions. And here's the syntax for it. Again, you assign something to a variable, you declare a variable. The variable now is going to become the function named. And here's the syntax for here's the arrow function syntax. So we don't use the actual word function anymore. So we've got this arrow, and what's to the left of the arrow is where you specify the parameters to the function, and what's to the right of the arrow is where you specify the body of the function. And again, the body has to be enclosed in curly braces. Now, that's fine. And saying down here, okay, you enclose the body with curly braces, unless the body of the function of your arrow function only consists of one statement. If that is the case, you can actually leave out the curly braces. So that's up. The curly braces are optional. Also, I'm saying here that you enclose the parentheses. Sorry, you enclose the parameters with parentheses, unless the function only requires one parameter, in which case you can leave the parentheses out. So again, this is slightly less syntax for you to type. And thirdly, if the function body only consists of one statement, and that statement is the return value of that function, then you can omit the return keyword. So putting all of that together, putting all of those optional parts together, then this example down here is a valid declaration using the arrow syntax of a function. I just tried to come up with something, so I came up with a function that computes whether a year is a leap year or not. The detail isn't that important, but from a syntax point of view, year is my parameter, but I'm not putting parentheses around it because there's only one parameter. The arrow separates the parameters from the body. The body is just some bit of computation that's done. And I don't have any curly braces. There's lots of parentheses being used in the body here, but that's only for control the order of evaluation of this big long statement or big long expression. And I don't have any curly braces though around the body because my arrow function only consists of one statement. So I didn't need to use the curly braces, and I don't have any return keyword because it turns out that this entire expression, which is going to be a Boolean, that is the return value for this arrow function. So I guess what I'm trying to get at is when you see this, it can be a little bit off-putting initially because there's so little syntax, but that's an example of an arrow function. In the extreme case, i.e. when it only consists, body only consists of one statement, and that is the return value of that statement, and it only has one parameter. But if none of those conditions apply, then you're back to kind of up here, right, where you're using the parentheses and you're using the curly braces, and you have to have an explicit return statement. Arrow functions, at the end of the day, they have to be converted back to plain old function declarations. Function expressions or function declarations. It can be either or. And all I'm showing you here in this screenshot is from a website called the Babel website, where on the left you can paste in kind of modern JavaScript code, and what the tool will do is it'll show you what the equivalent old style JavaScript code is. This is kind of ES5, this is ES6. The reason we always convert things back to old JavaScript is to ensure that our code will run on older platforms, like in older browsers and perhaps older versions of Node. And all TypeScript, as it turns out, is converted back to ES5 JavaScript. Yeah. Also, in JavaScript, we have this notion of higher order functions. You may or may not remember. Higher order functions is a function that takes a function as a parameter. And that parameter we refer to as a callback. That's just the label we put on. So if a function has a callback, that's another way of saying that one of its parameters is itself a function. And quite often we use the anonymous, which I haven't shown you an example of yet. We use the anonymous functions syntax for expressing callbacks. Anyway, so the function being the function parameter is termed a callback. That's fine. And here's a kind of generic example. So I've got this function called some HOF, and let's say it takes a couple of arguments, but the last argument is a callback, is a function. Now you can use anything you want to here. You can use a function expression, a function declaration. You can use an arrow function. It doesn't really matter. Although at this stage now, you'll mainly probably see arrow functions being used here. And certainly it tends to be anonymous functions as well, as I'm saying here. Now, to just give you an example of these higher order functions, I could have dreamt something up, or I could just show you kind of real life examples. So it turns out that the array data structure in JavaScript, remember I'm actually talking about JavaScript here, the array data structure has a number of methods which are of this higher order function characteristic. When we use the word method and function, we can actually kind of use them interchangeably, because a method in JavaScript at the end of the day has to be converted into functions. We don't need to know about what that conversion looks like, because I said there a while back that JavaScript, it does not actually have classes natively. It's not built into the language at all. So even though we write code, we write class-based code, object-oriented code, in other words, in JavaScript, that still has to be converted back into ES5 JavaScript, which has no support for classes. So, so the array, when I talk about array methods are really functions behind the scenes. That's just by the way, but we use the kind of method syntax that we're kind of familiar with from other object-oriented languages. So the array data structure, anyway, has a number of methods, and three in particular, although there are many more. The filter, the for each, the filter, the map, reduce, it has many others though. And each of these methods takes a function as an argument, as a parameter. So let's just see examples of that, so we get familiar with the syntax of using functions as parameters for other methods stroke functions. So here I've got an array, and it doesn't matter what the specifics of the elements are. It's an array of values. And here I'm calling the for each method on my array. And the for each, I can tell you, is a method that takes one parameter, and that parameter is a callback. And that looks like what's happening here, because here's the parameter. Where does it start and end? It starts and ends here, I think. Oops. Not very good drawing, but you can get it, trying to get what I'm get at here. That's the parameter for each, in this case, generic case, but it's a function. And this is an example of an anonymous function, because the function has no name. There's no point in giving it a name. And somewhere within the body of for each, and we don't have to look at it, what the for each does is it invokes this function once for each element in the source array. And for each invocation, it passes into the invocation the current element that's being processed, the index position of that element. It passes in the entire array, as it turns out. And then whatever the body of the function does, whatever the body of the callback does, it does it for that particular element. Okay, so it's a bit, so the for each is an alternative to, it's an alternative to the loop. How do I get rid of that drawing? Sorry, just give me a second. Okay. That's fine. I think that's pretty straightforward and everybody can understand that. But in terms of what we're trying to get at here, we would say that for each is an example of a higher order method stroke function, because it takes a function as a parameter. Right. Now, to the other ones that I want to look at, which is filter, map, and reduce, I'm going to just explain them or re-explain them if you're already familiar with them, by means of just some examples. And I'm going to be using an open API to illustrate these other three higher order functions. It's this random user web API. It's just an open API that you can invoke across the web. And what it does is, so if you send it a request, it will randomly generate what we call user profiles, which are just objects that contain randomly generated values for a user, like their first name, second name, address, date of birth, all that kind of stuff. And this is an example. This is the URL here. This is the OpenAPI's URL. And if you include this results query string and you set it to a value, so if I sent that request to this random user, this OpenAPI, what it would return to me is an array of 10 randomly generated user profile objects. Yeah, so that'll be my kind of test data for illustrating the other methods: filter, reduce, and map. Okay, let's look at the actual examples. So I'm back to the archive that I gave you last week, and if we go into the functions section, and I've got a subfolder here called review higher order functions. So this is, even though my file types are TS, it's really all JavaScript that I've put in there. Just 1 second now. Okay, so let's just quickly run through the code. So I'm using the fetch method that's built into Node and built into the browser. And you're probably familiar that the fetch method is a way of making a HTTP request across the across the web. And you give it a URL, and the URL I'm giving it is my random user. If I just do a mouse over on that and just actually, I can invoke it. Okay, that's the same as, so this is what you're seeing here now is the JSON data that has been returned by this open API. And if I make it just a little bit simpler first, because I'm requesting 10 user profiles there, so it's quite hard to break down that data. If I just ask it for one user profile. Okay, so what it returns is, it returns an object where the object actually only has one key called results, and the results has a value, which is an array, and it will be an array of user profiles. And you can study the detail of it later on. It's not that important to study the detail, but it's a whole set of key value pairs relating to a person, it looks like. Yeah. So there's a gender property, name, and so on and so forth. Back to my code. So I make a request to this open API, and I ask it for 10 profiles. Now, this has got nothing to do with higher order functions now, but the data that comes back from across the web, that's potentially, it could be fragmented as it travels across the network, and it has to be reassembled. So this line here is actually just reassembling all of the data that has come back into one structure. So a response body, as its name suggests, that now will be the body of the HTTP response that comes back from this particular API. And I've shown you there in the browser the structure of that. Then I'm indexing into the results property of that object, and I showed you that the results property will contain an array of user profiles, randomly generated user profiles. So this, and you can see here, I'm saying that this now is an array of profile. Sorry. It's an array of profiles. Now, a profile is something that I've actually just declared for myself. If I look at it here, I've got this, you can see this mytypes.d.ts file. And did I go into it? Didn't go into it, sorry. Let me just do that again. Here it is. And so that's actually, I probably should have shown you this at the outset, actually. That's the structure of a user profile. So that's fine. That will be useful to me. That's a TypeScript. I'm using the TypeScript. What am I using? The TypeScript. Sorry, that's an actual user profile. I just grabbed it when I was playing with this earlier on. I grabbed an actual user profile, and this is a trick you can do in TypeScript. If you see this line here, I wanted to create a data type from this actual data object instance. And there's a kind of a trick that you can use to do that, which is this type of operator. Kind of slightly gone off tangent now a little bit, but if you apply the type of operator to this data object, what it will create is a TypeScript data type for you. So hence profile now is, you can see here I'm using the type alias syntax. Profile is a custom type that I've defined for myself. Yeah. Okay, back to my code. So that's why I've said in my code that this here is going to be an array of profiles. So I've got my data now that I want to play around with using the higher order functions, which is where I want to get back to. So the first higher order function that I want to look at is the filter function. And if I go back to my slides, boom, boom, sorry. Yeah, so filter. Filter, again, it actually only takes one parameter, which is a function. And the way filter works is it selects a subset of elements from the source array and it puts them into what we'll call an output array. Okay, it doesn't actually change the source array, by the way. Okay, so it selects a subset, and the subset that it selects is controlled by the callback, because what filter does is it invokes the callback once for each element in the source array. Now, the callback in this case for filter, it has to return a Boolean. That's what's stipulated by filter itself. And if the Boolean value that's returned for a particular element in the array is true, then that element is included in the output array. If the callback returns a false, then that element is not included in the output array. Okay, so that's how filter works. And so what we're doing is we're taking the input array and filtering it by using whatever criteria we want to. The criteria is controlled by the callback. Source arrays are not changed. So here's an example of me using filter. So I have my array of profiles and I'm calling filter. And here is filter is a higher order function. And here is the callback that I'm passing to it. And my callback begins here and ends here. And you can see it looks like what I'm doing is I'm returning the Boolean value of gender, profile.gender, whether it's equal to female or not. So again, so filter invokes my callback once for each element. For each invocation, it will bind the parameter, the profile parameter. It will bind it to the current user profile object that's being processed. And I'm just referencing a particular property within that object, the gender property, and I'm checking to see, is it equal to the string female? Because I know, and we saw that from the browser, one of the properties happens to be the first property. One of the properties is a gender property, and it's either equal to male or female. As it turns out, that's the way the Open API works. So that's fine. Filter this particular, so when I console log, well, am I using for each? I'm using for each then to iterate over that output array. So this console log should output only all females within my array of profiles. And if I bring that up for myself and run it, let's see. The delay there is because it's actually making a HTTP call across the web. And you can study this later yourselves, but I can tell you that the first part that's output by this script is the console log that I've highlighted up here, and you can see it is actually all females. Now I have commented out this console.log. If I uncommented that, then you would see all of the profiles, and you'd see some of them are male and some of them are females. Now, also bear in mind that every time I run this program, it makes the HTTP call to my OpenAPI, and it's a different array of user profiles that's returned every time because it's always randomly generated. That's just by the way. So to get back to the core point which is higher order functions, that's what we're talking about. Filter is an example of a higher order function, stroke method. And in this case, we're using the arrow syntax for declaring the callback that I'm passing to filter. Okay, and this is an example of an anonymous function. And it can be difficult to read this code sometimes initially when you come across it, because burying function calls within function calls can be, syntactically, it can be quite clumsy. And I've got one or two other examples as well, I think. Do I? Filter. Yeah, in this example here, supposing my objective is this. I want to get all males under 40. And so here's my callback in that case. And in this case, and I'm being very efficient with the syntax because I have no parentheses I have no parentheses wrapping the parameter of my callback. I don't have any curly braces. I don't have any return statement. Okay, whereas I had all of those up here, right? I was doing a lot of extra syntax, including a lot of syntax in this one, which I didn't really need to. Yeah, so again, you can study that later on yourselves. And do I have a third example? Don't think I do. No. Right, that's filter, and it's an example of a higher order function where the callback, in both cases, I'm using the arrow function syntax, and I'm using it in the form of an anonymous function when I'm passing my callback to filter. Map, going back to my slides. Map is another example of a higher order function. Coincidentally, it also only takes one parameter, which is also a callback. What map does though is it returns an array where the number of elements in the array is the same as the number of elements in the source array, but the output array in this case is controlled by whatever the callback returns. So typically the callback might return a primitive value or an object. It could return a Boolean, but if it's a Boolean, then it means that the output array is just an array of Boolean true or falses, and that might make sense in some cases. Whereas filter always returns an array where each element in the output the array is the same type of element as there was in the source array. In the case of map, and typically in filter, there are fewer elements in the output array than in the source array. In the case of map, it's a one-to-one, same number of elements in the output array as the source array, but the actual elements in the output array is whatever is returned by the callback. And what are we doing in the sample code? So I'm using my array of profiles again. Let's see. So here's my objective. I want to create an array of just profiles emails, just their name and their email, I think is what I want. And if I look at the output, I want this kind of array here. Sorry, this kind of, array, of objects. Where each object has a user's name and their email address. So a lot of the other properties are ignored. And here I'm calling, so I have my original source array containing my user profiles. I'm mapping over them, and here's the callback that I'm passing. Just collapse that there. Here's the callback. And again, I'm using the arrow syntax. Didn't have to, but it seems like I'm using the arrow syntax for pretty much all the cases. And you can see that what's being returned is an object. Keeps happening to me. What's being returned is an object, and that structure, that object is consistent with what I showed you there a moment ago, down there. Yeah. I'm kind of ignoring TypeScript now for the moment because this is really a review of JavaScript. We don't have, if I was doing proper TypeScript now, I would have either an interface data type or a type alias, which defined this type here. And then I would say I'm returning an array of a certain type and all that kind of stuff. Because if I use Command K, Command I on this, it's just saying it's an array of objects of this structure, which is right. Okay, it has made that up for me, which is fine. I don't have a name for this structure though, which I probably should have if it was proper TypeScript. That's map. Do I have a second example of map? Yeah, so let's suppose I want to create an array with just the array of numeric values, the ages of the various users, as in this array here. Yeah. So again, I'm using map to map over my source array and output. Sorry, where have I got it? Oh yeah, the callback is very short in this case. That's the callback. Sorry, that's not the one. Sorry, am I getting mixed up a little bit? Oh yeah, yeah. Yeah, that's the callback. The age is actually stored inside. It looks like the age is stored inside a property called DOB for date of birth within my profile. And if I just go back to my types array or my types file, this one here. Let's see. Where's date of birth? There we see date of birth there. And it's broken up into a date and an age. Yeah. So that looks okay. Anyway, at the more general level, map is another example of a higher order function, stroke method. And finally, the last one we look at is the reduce. The reduce higher order function. The reduce takes two arguments. The first argument is a callback. So that's all of this stuff here. And the second argument, which is this one here, the second argument is what's called the initial value of the accumulator. So what reduce does is it processes your array and it computes an accumulator for that array. Now the accumulator can be anything. It could be a numeric value. It could be an object. Can be anything you want it to be. Whereas map and filter were very specific. Map and filter always returned an array of things. Reduce is quite different. As the name suggests, with reduce, we want to reduce our source array into a single value, which we call the accumulator. And what you need to do in the callback that you pass to reduce is, the purpose of the callback is to incrementally build the accumulator. And so the way it works is, again, the reduce method calls your callback function once for each element in the array. And within the body of that callback, it needs to take the current value of the accumulator and modify it to account for the current entry that's being processed. and then return the updated accumulator after that computation. The signature of the callback is different now from the signature of the callback for the other two, as in the first parameter of the signature for the callback, it's a bit of a loaded sentence, the first parameter is the current value of the accumulator. So let me just clear all that again. So to put it another way, the first time the reduce method calls my accumulator, this parameter here is going to be equal to this because it's the first time, and this is the initial value for the accumulator. So that's going to be the value of this first parameter. Within the body, I do some computation. I take the current value of the accumulator and I update it based on some properties of the current element that's being processed. And I return the updated accumulator that has been computed. This updated value now becomes the first parameter of the second invocation of my callback. And again, the body takes the current value, which is now the second value that has been computed, it updates it and returns it. So if you like, there's a link between what's returned here and what's passed as the first parameter to my callback. That's the way the reduce method works. So you can read the bullet points there, but just maybe to give you one or two examples. So my objective is I want to let's see what I want to do. I want to compute the average age. Sorry, wrong one. This one up here. I want to calculate the average age of all of my profiles. So what I'll do is I'll use the reduce method to compute the total of all of the ages, and then I'll just divide that by the number of profiles in the array. So my reducer now is not actually going to compute the average, it's going to compute the total number of ages. And here I am invoking reduce on my array of profiles. And in my callback, here's the initial value for the accumulator, setting it to 0. And here's what the callback returns. So it's taking the first parameter, it's taking total, which initially will be set to 0. And it's recomputing total based on this simple little algorithm here. Oh yeah, it's just updating. It's adding the age of the current person to the total and returning that. And that now becomes a new value for total in the second invocation of my callback, and on it goes. Okay, so the reducer there in that case is computing the total of the ages. And then I just do a computation. I do a computation by dividing it here by the length of the array. Second example using the reducer is supposing I want to find the youngest person in my array. Now, there are a couple of tricks when you're using the reduce method, and one of them is getting the initial value of the accumulator right, because that can dictate whether your reducer works properly or not. Now, in this case, assuming nobody's going to be older than 100, I set the initial value of my accumulator to 100. And in the body of the callback, essentially every time I'm looking at the current profile that's being analyzed, I'm looking at the age property within that profile, and I'm checking to see, is it less than the current minimum age that I have found, where min here now is the first parameter of the callback. And if the current person is younger than the current minimum, then return that person's age as being the new minimum. Otherwise, just return the current minimum as being the youngest that we've found so far. So you might need to just glance over that code to confirm that it's doing what it's supposed to do. All right, that's a very quick review of some sample higher order functions in JavaScript. But of course, we're doing TypeScript. So what do we want to know? How is this going to, or where are we going to use this? How are we going to use this in TypeScript, or how is it going to affect our TypeScript? And so if a parameter of a higher order function in TypeScript, well, it's not if a parameter, but because one of the parameters of a higher order function in TypeScript is a function, how do we declare the type for that function? Because we have to, in TypeScript, we have to declare the types of the parameters of a function. And if one of them happens to be a callback, what's the syntax for declaring the type for that callback? So here we go. Here I've got a function. It's not a very useful or interesting one called print to console. Sorry. Called print to console. It takes two arguments, it looks like. It takes a string, and the second argument is a callback or a function. And this is the syntax that we use for declaring the type of the function. Essentially, you have to declare the signature of that function. So you're controlling here, you're saying that this print to console function, whenever it's invoked, it has to be passed as the first argument a string, and the second argument has to be a function. That function has to be one that takes a single parameter of type string, and that function has to return a string as its return value. What the function does, we don't care about in the declaration of the type of the callback, but the signature has to honor this here. So that's the syntax that we use for declaring the type for a callback in a higher order function. As I said, the function doesn't do anything interesting. Here's another example. So I've got an array mutator function, and the idea here is that this function takes an array of numbers and it mutates that array. In other words, it creates a new array where each entry in the new array is a mutation of the corresponding entry in the input array, if you like. So this is my input array, and the second argument then is a callback which produces the elements of the output array. So it's going to be a function, and in this case, the signature of the function is such that it takes a number and returns a number. And so coincidentally, it's returning and taking the same type, which happens to be the same up here, but that's just a coincidence. Let's see some examples of that. In this case, now we go back to our, we close off that folder. Close off all of those. And we go back to our index dot. Just before I do that, maybe just before I look at that, here's an example of of arrow functions in TypeScript. That's probably not a whole lot. Let me just see. So here's a function that takes a string and the second string, and it returns a string. That's all fairly understandable to you at this stage. Here's another example of an arrow function. The thinking that was going on in my head at this stage for this one was you give it a string and you give it what I'm calling an axis, sorry. And what the function does is it looks for the axis in this source string, and it rotates the string around the axis. And I've just decided that the axis could be specified as a string, as a static string, or it could be specified as a regular expression. And the function works its way through it, which you can look at yourselves. I don't want to get bogged down in that now. It's just code anyway, so Yeah, I'm just going to move on really because I'm conscious of time. Let's see. Right, higher order functions. That's the one we had on the screenshot. That's okay. What I've commented out here, like, is just, you know, the callback. I'm specifying the signature of the callback, and so the compiler will obviously complain if you invoke this print to console with a callback that doesn't match the signature that we've specified here. And I think, is that what I've got up? But yeah, if I uncomment this, so I'm calling print in console and passing a string as the first argument, that's okay. But here's the function, and the function takes a number and it returns a number. And that's not consistent with what I'm specifying up here, which is the callback should take a string and return a string. And so the compiler catches that obviously enough and complains about it. Probably too obvious an example, but let's go on to our array mutator. So that's fine. So this is what I had on the PowerPoint slides. And here I'm calling my array mutator function. I'm passing it an array of numbers, and I'm passing it my callback. And the callback, it looks like it just multiplies each number in the array by 10. So I guess I should get back 10, 20, 30. That should be the result. And this console.log is output to the terminal, and let's just make sure that's what we get. The first two console logs comes from that rotate method, that rotate function, which you can look at yourselves. So this is the output of the console.log that I've just been talking about right now. So it is giving us 10, 20, 30. That's fine. Here's another example where I'm calling oh no, in this case, I'm just declaring an arrow. What am I doing here? Sorry, oh yeah. Um, I'm just declaring a function using the arrow syntax, and this function takes one parameter of type number, and it does a computation on that number, checks to see if it's greater than 100. If it is, it returns the number. If it's greater than 100, it returns that number minus 10% of it. So it kind of reduces the value of the number. Otherwise, it just returns the number itself. Now that's going to be actually I want that to be my mutator. So here I am calling the array mutator, and I'm passing it the function that I just defined there just above it. And that function's signature is correct. That matches the mutator callback signature. And so the output, when I console log that, the output is this one here. So it reduced what did I pass in? I passed in 110, 20, and 300. So it should, in the output array, it should reduce the 110 by 10%. It should reduce the 300 by 10%, and it should leave the 20 alone. And that's what we're getting down here. Now, just to go off on a slight tangent, but with an intention. This syntax can, let's see, this syntax can get a little bit difficult to read, can be difficult to read. So not in this small example, obviously, but more generally in a large code base, it can be difficult. When somebody is reading, you always have to be conscious of other people reading your code and make sure that it's easy for them to understand your code. So when we've got these kind of things buried inside function declaration, It can be difficult to follow the flow of control. So what you can do is you can actually use type aliases to make the code arguably slightly easier to read. And that's what we're doing here, right? So I'm using the type alias syntax to declare a type, and I've called my type mutator function. But the type actually is a function signature. And that now means I can use this in my array mutator function, as in here. So I've got a new function called array mutator version 2. Array mutator 2. It takes an array of numbers and it takes a second argument, and the second argument is of type that. And that then gets its value, if you like. That gets its, well, it's not its value, it gets its full, its expanded type from this line here. And so if there were lots of cases where we had a callback and the signature of the callback was this, then rather than, that appearing everywhere, arguably anyway, I think it's easier to read our code when we're using something more English-like in the declaration. So that's an example of where type aliases can be leveraged. You can't use interface data types for this purpose. So it's a new kind of example of a use case for type aliases. In the bottom here, I'm talking about, I'm actually moving on to the area of promises. Promises we know is an important concept in JavaScript stroke TypeScript. There's well, in JavaScript, sorry. So does TypeScript understand promises? And I've got a function here, which it looks like it returns a promise of a string. Okay, it's hard-coded to return this particular string, but the return type is a promise of a string. Now I wonder, how does TypeScript represent that return type for this function? Because I'm not actually declaring it, and I've not declared it purposefully so that I can demonstrate this. But if I do Command K, Command I, clearly the function takes the string. We're being explicit about that. But to work out what the return type is, if I do Command K, Command I, it's telling me that yikes, I hate the way it does that. It's telling me that the return type is a promise of a string. Now that those angle brackets around string, we'll see those a little bit later on there. That's what's called generics. But the point I'm trying to make is that TypeScript compiler was able to work out the return type when the return type is actually something other than the standard primitive or a standard array or a type, a custom type that we have defined, something slightly more elaborate than that. Second example here is where I've got a function that returns a promise of a person. So I've just hard-coded a person object here. Person is a type that I've defined in my types.d.ts file. I don't need to show you that now, but it's declared there. And here I'm returning a promise of a person. And so is TypeScript able to work that out? Is the compiler? Again, looks like it can work that out as well. So that's another example of the power of type inferencing going on for us. Right, let's drop functions for now and talk about something called optionals. This is back in the world of data structures, I guess. Sometimes you might have a data structure or a data type, which is an object, but some of the properties of the object are not mandatory, which means you might get instances of that data type where certain properties are not included. And that's still a valid instance of that particular data type. So how do you express that in your data type declaration. And you can use either type aliases or the interface data type for these optionals. So here I've got an example of a user data type. And it looks like a user has an ID property, a name property, and the email property here has a question mark. And the question mark tells me and tells the compiler that email is an optional property within a user instance. So you can have user objects that do not have an email property and the compiler won't complain about it. Also, users optionally have a social property. And the social property is made up of a number of sub-properties. And the way you interpret it is that if a user does have a social property, then inside that social property, there must be a Facebook property, and optionally, there can be a Twitter and Instagram properties, but it must have this one. And finally, there's a status property, which is mandatory. Let's look at some examples, though I think it's fairly straightforward. So move on to here. There's my user structure as I had in the slides. And here I've got some examples of users. So it looks like Joe. Joe doesn't have an email, but Joe does have a social property. And according to my structure definition, there must be a Facebook, and that is the case. If I leave out Facebook, then the compiler is going to complain, even though social is optional. But because it's occurring in this one, based on the definition, there must be a Facebook property within social. Jane has an email, doesn't have a social, and Jill has an email and has a social and has a Facebook and a Twitter. Okay, so they're all valid examples, and there are no compiler errors occurring in any of those three instances of user, even though they're all quite different in terms of their makeup, or somewhat different anyway. The optional, what would you call it? An operator, I suppose. You can also use that with function parameters to indicate that a function parameter is optional. And so here we have a function called print ingredients, which takes three parameters, one of type string, which is mandatory, second of type string, which is mandatory, and the third one so happens to be of type string, but the third one is optional. And so a couple of invocations of it. Here I'm invoking it with only two parameters, but that's okay. Here I'm invoking it with three parameters, and that's okay as well. Oh yeah. The optional parameters have to be the latter parameters in the parameter list. You cannot have a mandatory parameter after an optional one. So for example, what you cannot do is the following. If I take quantity and make it the last parameter, then you can see the compiler is complaining. And if I bring up my problems tab, it essentially will tell you that a required parameter cannot follow an optional one. So that's the only constraint with using optionals for function parameters. Okay, that's that. Pretty straightforward. Union types and type literals. This goes back to type aliases again, and this is another use case for type aliases which interface data types do not support. Union types first. Sometimes you want to declare a type which could have more than one possible type of value associated with it. And so we've actually seen an example of this last week, but I kind of skipped over it because I said we covered more formally. So this is the formal covering of it. So here's an example. I'm declaring a type called size, and I'm saying it could be a string or a number. So we would say that size now is an example of a union type where this is interpreted as an OR. Here are some variables that are of type size. The first one, glass size, it's of type size, and I'm assigning it a string, and that's okay because that's consistent with here. Whereas I've got another variable called bottle size, it's of type size, but it's actually assigned a number. So the compiler is going to complain about any of that syntax. Another example of a union type, let's say I've got a type called role, and I'm saying it could be a student type, a lecturer type, or a manager type, assuming that I've declared these other types somewhere else in my code base. And you can mix and match. This might be declared using the interface data type syntax. This could be declared using a type alias. This could be declared using a type alias. You can mix and match type aliases and interface data types. They're interchangeable. They're interchangeable for just defining standard data structures. Okay. As I said, you cannot use the interface data type syntax for declaring union types. It has to be a type alias syntax. So that's union types. Literal types are types where you are constraining the actual values that instances of that type can have. So it's a bit like an enumerated type from other languages. And if we look at an example, I'm declaring a type here called degree nomination. And I'm saying this is a type now, not a variable. I'm saying the degree nomination type is going to be either the string BSC or this string or this string or this string. So if you subsequently declared a variable of type degree nomination, then the value you can assign to that variable has to be one of these 4 strings. The compiler won't accept anything else. There's some examples of that, I think. Oh, sorry, sorry. Can I just go back a little bit on? Sorry, no, just bear with me for a second. Yeah, jumping around a little bit now, but if I just go back to this example here, why do I want to? Okay. Oh yes, no, it's still on type aliases. That's okay. So type aliases, the point I'm making in this comment here, is, type aliases allow us to write more readable code. And an example of that was when I declared this mutator function type earlier on, just arguably anyway allowed us to write more readable code. This is in the other file now, not in this file. But here's another example of how we might use type aliases. So I'm defining a type called social handles, which looks like this. I'm defining a type called address, which looks like this. I'm defining a type called contact, which could be this is an example of a union type. A contact type, I'm saying, could be either a social handle or it could be an address. So I'm building up my type hierarchy, if you like. And here I've got a user version 2, and one of the properties is contact, and the type of that property is contact as well, where contact comes from up here. And that now means that, for example, if Kyle is an example of a user version 2, and here's Kyle's contact property, and it looks like it's following the kind of social handles structure that I defined there. Yeah, whereas Jenny is a user version 2, but Jenny's contact property is following the address structure that I defined. And get contact, yeah. And again, although I've only given 1 or 2 examples of it, the other great thing about the compiler is that it's always kind of helping you behind the scenes. So, as I was writing this code, so I had written, let's say, that much, and the next thing I'm going to do is go, let's see, boom, boom. Oh yeah, T, and it's helping me straight away. Like it said, look, this is what you want to type. Um, so you just don't make silly mistakes. That's what the TypeScript compiler is great at catching as well. It doesn't allow you to create invalid structures, which uh, won't be spotted until you run your code. Try to undo that. No, sorry. Right. I've got a function here. I just want to illustrate another aspect of the compiler's power. So I've got a function here called getContact, and the idea is I pass it in a parameter of type user v2, and the function is meant to return in the form of a string the contact detail for that particular user. But we now know that contact could be in the form of an address, or it could be in the form of um, social handles. Okay. And so in the body of my function, I have to determine, well, what type of contact information does a particular user have? And so this statement here, this condition statement, is checking to see, does the contact property of my user, does it contain a street property within it? And if it does, then that obviously tells us that it's the address form. Now, the point I'm trying to want to get to though is if I do a control command K command I of contact, this contact here, it will actually, compiler will work out based on the preceding condition statement that it must be of type address. So if I do command K command I, it does work it out that it's of type address. What the compiler is doing here is it's performing what's called type narrowing. It's narrowing down, in this case, the contact type. It's narrowing it down into either an address type or a social handles type. And based on the flow of control, because I am doing a return statement here, based on the flow of control, then that must mean that down here, any occurrence of contact must be of type social handle. So if I do command K, command I on this one, it works it out correctly as well. Did it work it out correctly? Sorry, that one is just staying on the screen. Let me just get rid of it. Command K, command I. Yep, worked it out as well. So, and one of the benefits of that type narrowing that the compiler does is if I go on here and let's supposing I want to reference a particular property within my contact. So I go contact dot. You see, it's telling me, look, the only 2 properties that you can reference are street and town. Again, because it knows that within the body, within the if the true part of this if statement, Contact has to be of type address. So these are the only valid properties. It won't allow you to dereference contact with by any other property. In other words, you just can't make a what I keep calling kind of silly mistakes in your code. The compiler will catch them before you get to try and do that. Whereas that wouldn't be the case in JavaScript. Okay, that's just by the way, that's something called type narrowing. And back to literal types. Here's another example of a literal type. I've got a department here, so it can be either equal to engineering, sales, or accountancy. And okay, that's just an example, I guess. Well, no, let's follow through on it. Here I've got an if statement, and again, as I was typing this code, if let's say I undo some of this. So I'm doing a check here, and I want to see if it's equal to what. So as I type, again, the compiler is helping me. Can only be one of these three strings. Won't allow you to type anything else. So what did I have it? I think I had it as an accountancy. So again, that's another nice aid that the compiler gives us as we're actually writing our code. Okay, they're union types and literal types. Next is something called generics. Generics is something that's available in lots of languages. The first place I came across it was in Java many, many years ago, so it's by no means unique to TypeScript. The general idea is with generics is this aim of having reusable components within your code base, whatever a component is. A component could be a function or a class, okay, but to try and make them reusable. So how can we make, but reusable in this sense, in the sense of being able to work with different data types. That's the aspect of reusability that we're trying to get at with generics. So just to read a sentence, so okay, major part of software engineering is building components that do not just only have well-defined interfaces, but are also reusable. They can be used for multiple data types. Generics allows us to create type variables, I suppose, rather than reading it really. If I give you talked about the exact example here. So I've got a function. Here, and I've purposely given it a meaningless name called process. And the function takes one parameter. But this part of the function declaration here is the generics part. And how you interpret it is T here is it's a type variable, which I'm mentioning up here. It's a variable whose value can be a type. Normally, variables have a value that's representing data, like an actual string, an actual number, 23. But here with generics, we have variables that can take on a type value, which sounds contradictory, but okay. But I'll just push on anyway. So T here is a variable, and you can give any name to this type variable that you want to. T is a convention, but you can give it a more elaborate name. And it looks like this function takes a parameter of type T, but we're not being specific about what type T is in our declaration of the function. And it takes a second parameter of type number. That's okay. And presumably in the body of the function, it does some processing of this T variable. But what type is T? Well, you actually assign a type to the T variable when you invoke the function. And here we are invoking our function, and we're saying for this particular invocation, I want T to be a person type. A person is, let's say, a custom type that I've defined elsewhere in my code base, which means that this parameter here, okay, its name suggests that it is probably a person, but this parameter has to be an object of type person, because when I declared my function up here, I said that the first parameter has to be of type T. And now I've instantiated, if you like, I've bound person to this variable T. So person X better be an object of type person, otherwise the compiler will throw a complaint. As I said, there's no significance to the actual name here. T can be anything, can be U, could be K is another one that's often used, but it's just a convention. Here's another invocation of my function. And in this invocation, I'm saying that T is bound to the box type, and which means that this better be an object of type box. Now, clearly inside in the body of this function, I do need to maybe work out, well, what type is T, and then do my processing accordingly with some sort of if statement or case switch statement or whatever. So I would say that this process function is a function that is utilizing generics, and it can be reused for many different data types. Now, it may not be an infinite number of data types. There may be some restriction on it, and that's why I'm being vague about what exactly the function actually does. Let's see a more concrete example of this going on. So if we go into here, so we need to build this up now, this example. Just by way of background, the JavaScript language has a method called sort associated with arrays, back to our arrays, coincidentally. And the sort method does what you think it does. It sorts the entries in my source array. Now, coincidentally, and it's of no real significance, but the sort method, unlike filter and map and reduce, the sort method does actually alter the source array. That's just coincidental. It's not significant though. The sort method is also, coincidentally, a higher order function, which takes a callback as its only parameter. And the purpose of the callback is to control how the sort method should reorganize the entries in this array. It's the basis for the sorting, in other words. And if you read up on the sort method, you would see that this callback function, it has to be a function that takes two arguments, and A and B will be of the same type as the entries in the array. And the function has to return a numeric value. And the numeric value tells the sort whether it should position B before A or A before B in the array, where A and B are typically adjacent elements in the array. So it controls whether it should swap the two elements in their position in the array or not. Okay, so the callback has to take two arguments, and the callback has to return a numeric value. If the numeric value is negative, then that means B is, quote, bigger than A, so it should appear after A in the ordering. If the callback returns 0, it means B and A are of the same magnitude, so it doesn't matter whether you can leave them in their current position in the array. And if the callback returns a positive value, then that means that A is actually bigger than B, and so their relative position has to be swapped within the array. Okay, that's just all by way of background, right? Now, let's supposing we did not have generics available to us. So I've got a function here called string ranker, and the purpose of this function is to take an array of strings and to rank them, or order them, which is a bit like what sort does, admittedly, but there's a method to my madness here. So here's my custom function called string ranker. It takes an array of strings, that's fine, and it takes a callback function, which I've called ranker, and it's a function that takes a string and returns a number. And this ranker function is going to help me in the code that I'm writing in the body of this custom function of mine. And really all it's doing is it's calling sort. It's calling sort and it's using the ranker function on A and B to essentially do the same thing that I was defining up here, where I was being specific about, I was using the length of the strings. Okay, so that's a string. This is my custom function called string ranker, which admittedly is a pretty useless function because it's why I can just use the string sort and I don't use this this wrapper function, but just bear with me. So that's fine. And it returns an array of strings. I've got another function called person ranker. Sorry, I'm just invoking the string ranker here. So, okay, that's fine. I've got another function called person ranker. This one takes an array of person objects and it takes a callback function. And the purpose of the callback function is to help me to organize the array of persons in a certain order based on some criteria. And the criteria is controlled by this ranker function. The ranker function in this case takes a single argument of type person and it returns number again because I am actually going to be using sort within this person ranker function as well. So I'm leveraging sort in both cases. Now, my two functions, the string ranker and the person ranker, they're almost identical. In fact, they probably are. The body of them is identical. The body of them, sorry, the body of those two functions is identical. So can I not combine those two functions into one? And this is where generics come in. So rather than, whereas up here I'm being specific in saying that it's an array of strings, or it's an array of person objects, let's use generics. And here's the form of the function. There are just some examples of it there of the other ones being invoked. Here's a new function, and here I am using generics. And again, I use T, but that's just coincidence. So this function is a generics function. It takes an array of T's, and it takes a callback. But the callback is a function that takes a single parameter. The single parameter is of type T. And as always, it returns a number. That always has to be the case. Otherwise, my sort isn't really going to work for me. And here's the body of the function. And the body of this function is really the same as the body of the other examples of it, the specific use examples of it, or the specific instantiations of it, I guess. Now, but with my sorter function, how do I invoke it? And it's not until I invoke it that I am specific about what type of array am I trying to process. And so that's what I'm doing here. I'm calling the, well, technically what I'm doing here is I'm creating a new function, but the function is based on my sorter, where the type parameter is person in this case. And I am giving it an array of person objects. They're the ones that I defined earlier on in the script. And I'm passing it my ranker function. Now, you might ask, what's this all about? And when I was kind of preparing this stuff, I said, well, I can actually leave all of that out if I make a change to the person structure. Let me go back and show you what the structure of person was. There was a good reason why I did it at the time. I can't think of why it was a good reason now, though, but here's my person structure. And for whatever reason, I said, let's make age optional, which means that in my array of person objects, there could be a person that has no age property, i.e. undefined. So how does my sort, which is eventually going to have to process my array of person objects, how does it work with an age that's undefined? So that was the problem, right? Now I could have made life simple for myself and just went back to my person structure and just made age mandatory, and then everything is straightforward. But I said I wouldn't, and for the purpose of explaining another aspect of the compiler, really. So let's go back to where we were. So if I didn't, if I didn't, uh, if I tried to ignore the fact that age could be undefined, in other words, take out all of that, then straight away the compiler is complaining to me. And the reason it's complaining is, so my ranker function, let's see now, can we follow the flow? My ranker function is a function that takes a single property of type t and returns a number. But if age could potentially be undefined, that means that this expression here is undefined. So it's not honoring the signature of the ranker function. It could be a numeric value or it could be undefined. And the compiler is telling me you've got to handle the situation of the occurrence of undefined being the value for age. And so I just arbitrarily said, well, if I get a person object, that doesn't have an age in it, then just use 30 as the age for that person. Just an arbitrary decision that I made. This is this question mark here is it's got nothing to do with option. It's the ternary operator, JavaScript ternary operator. It's kind of a shorthand for an if. So the way you read this line of code here is if p.age is something other than undefined, then return p.age. Otherwise, return 30. So that's the reasoning why I have all of this stuff, this extra little stuff here, which has got nothing to do with generics, as it turns out. But I'm nothing if I don't complicate things to myself. Right, back to generics. So that's an example of where we're calling our generics function sorter in this case with person as the type for my generic type variable. I guess what I'd like you to be able to achieve is to be able to read generics based TypeScript code. You won't necessarily be expected to write functions or whatever using generics, to design them yourselves. I'm not expecting you to get to that level, even though maybe it's one of the little exercises in the lab, but beyond this week's lab, then we'll see a lot of generics code, okay, and it's important that you can understand the code and read it and make sense of it, but you won't be writing custom code that's leveraging generics, which you kind of designed yourself, just in case you're wondering, because it's quite a heavy topic. What am I doing here? Okay, here I'm using the starter again. Oddly though, I'm not actually specifying any value for t here. I'm not using the generics, but this is the same sorter, and I'm passing it an array of strings. And here's my ranker function, and again, I'm just using length for simplicity's sake as the basis for ranking my array of strings. So the question is, why did I not use the angle brackets here? And the answer is type inferencing actually took care of it for me. If I actually put in, well, let's do Command K, Command I, sorry. Let's do Command K, Command I. You can see it has actually worked it out that it's that T is a string in this case. Now, how did it work that out? Well, it looked at this and it says, well, that's an array of strings. And when I declared the sorter function, I said that whatever type is associated with this array, that matches the type here. So it just worked back to that. So again, it's just type inferencing at play there. But as a beginner TypeScript programmer, which you would be, then you more than likely would have been explicit and put in string there, and that's fine. Okay, what's next? Yeah, so I'm using generics there for making a function reusable, but you can actually use generics right across the board. You can use it with classes, and we'll see examples of that when I start talking about um, looking at some AWS stuff. But you can use it in interfaces and type aliases as well. So here's an example. So I'm using the data interface type to define a microphone structure. Standard enough. I've got another speaker structure here. And now I've got a box structure and I'm using generics. And this is going to allow me to have boxes in my code that could be boxes of different contents, if you like. Each box has a shelf number of type number, and it has a content, which is an array of T. And so here's a specific example, a specific instance of a box, if you like. So I've got box 1 is a box that contains speakers, if you like. T is speaker. And, I'm hard coding the contents. So generics can be extremely useful right across the board. The difficult thing, I suppose, the challenge usually with generics is identifying an opportunity to use it. Reading the code, I think, is okay once it's explained, and hopefully I've done that. It's easy enough to read code that contains generics and make sense of it. The difficult part often is seeing an opportunity to avail of generics. And I don't necessarily expect you to be at that latter level. Right. The last thing I want to look at is utility types. And what utility types allow us to do is to take a custom type that I have defined for myself and transform it into another type, or put another way, to define a type that is based on a transformation of another type. Okay, and that's something that we can find ourselves doing quite a lot in TypeScript development. And there are various utility types. So the utility type enables us to take one type and produce another type from it by means of some sort of transformation. And there are lots of these utility types, or lots of types of transformations that are built into the TypeScript language. And there are some other ones that have been added by the open source community. Let's look at one or two examples. So we're down into this folder here. So I've got a tech user, standard tech user defined using the interface data type. So tech user has these properties. And let's supposing I want to define a type that is the exact same structure as tech user, but I want all of the properties to be optional. Now, I could take the long-winded approach and just do a cut and paste and make all of the things optional myself. But there's a utility type that will do that for me. And in this case, the utility type is called the partial type. And the way you invoke, if you like, these utility types is we're kind of using the syntax of generics. I suppose it is generics in a way, but I wouldn't tend to look at it that way or interpret it that way. So here I'm using the partial utility type, and I'm essentially telling it, take this source type and create a version of it where each property in the new version, each property is optional. And if I do Command K, Command I on this new type, you can see that all the properties indeed are, all the properties are optional. Okay, so Mission accomplished. Okay, I'm using just a function there that's using both of them. You can read that yourselves. Another example is the opposite of partial, I suppose. There's the required utility type. What that does is it takes your source type and it transforms it into another type where each entry in the transformed type, each property is mandatory or required. So because I had email, if you look, I had email as being an optional type in tech user. When I look at the full definition of this, what do I call it, required user, if I do Command K, Command I on that, you can see that email is mandatory, as are all the other properties. Pick is another example of a utility type. And what pick allows you to do is take a source type and pick out particular properties within it and make those properties the full set of properties in a new type. So it looks like I want to just pick out from tech user, I want to pick out email and name, only those two, and put that into this new type for myself. And again, that's what it's done. Sorry. Yeah, and it has retained the fact that email is optional because that's what was the case in my kind of source tab, if you like. Now, like what's nice about this is that over time, if I make changes to my tech user type, then those changes will kind of ripple through these other types that are based on tech user. Whereas if I took the copy and paste approach, then I have to manually make changes to the other types that are based on tech user. I guess that's the rationale for all of this. So that's pick. The opposite is a utility type called omit, um, which takes a source type and omits the list that you specified from that source type. It omits them from the new type that it's creating. So again, if I looked at the structure of this type here, it should not have ID and email in it, but it should have all the other, yeah, it should have all the other properties. That's that. I'm not going to look at that record type because we don't see it. We don't really use it that much, if at all, actually. Okay. I suppose at this stage now, if I go back to the lab, and you can see from the different sections in the lab, I'm giving you an opportunity to practice everything that we've talked about. So, you can practice interface data types, and pretty much each of these sections, I give you code so that you can see what particular aspect of the language you can see it being used in a particular example. But in most cases, I also have an exercise at the end of the section, so you get an opportunity to try and come up with solutions using the particular TypeScript technique that's being discussed within the section. So, we've talked about interface data types, we've talked about functions, we've talked about optionals, we've talked about type aliases, generics, and finally, we've talked about utility types. So there's a lot actually going on in this lab. And so you can work at this stage now. I've tried to give you an introduction to each of these topics, and you need to see whether you can actually complete the lab and complete the exercises. And in many cases, try and use those higher order functions, those filter map, and maybe even reduce, although reduce is quite a tricky one to work with. If you get an opportunity to use them, you should try and use them. Like I don't know that I mentioned it in the slides or not, but filter map and reduce, there's a simpler way of achieving the same outcome without using them, and that would be just use some sort of standard for loop to go through the entries in your array, and within the body of the for loop, that's where you generate the entries in the resulting array. But rather than using for loops, you should use filter map and reduce instead, because it is cleaner code and there is physically less code that you have to write, and the intent of the code is clear to anybody else that's reading your code. When you're reading a for loop, you really don't know what the for loop is doing. When somebody else is reading your for loop, they don't know what the for loop is doing until they've read the entire body of the for loop. Whereas when you're reading code and it's using filter and you see filter, then you know straight away, well, this code is clearly looking at a source array and producing a subset or extracting a subset of entries from it. You know that straight away by virtue of the fact that filter is being used. Now, what entries are being included in the output array? Okay, you have to look at the callback, admittedly, to work that out. Anyway, I'd like you to work through the rest of this lab. Should try and get it done for this week, I guess. And next week, then I'm going to start into looking at AWS and looking at infrastructure as code. So we'll start gradually moving towards the ultimate objective, which is to develop a serverless backend for a web app. As usual, I don't pause for questions, but I'm happy to take any questions, whether they be specific to what I've been working my way through, or more general questions. No. Okay, I will meet you on Friday in that case. Thanks for tuning in.